Good day to you all. We've now had clear statements of intent from both the governments in the UK and the US. They want to be more agile. So let's see what's happening in the UK with IT project management, look at a case study from the United States, and let's understand what we mean by agile project management. In putting together this talk, I know there's going to be people who are on this webinar who are very expert on agile, and conversely, maybe there are some project managers who have only heard of the word and want to know more about it. Also, there may be some business people who are just generally interested in project management and want to find out what agile project management is. So both the US and UK governments say they want to be more agile. They say things like they want to integrate IT into government processes, have less paperwork, have shorter, more focused IT projects to get early real-world feedback from pilots and roll out in an incremental fashion. In fact, both in the US and the UK, some pilot projects have started to use this new idea of agile. But what is agile project management? What is wrong with using traditional project management techniques with IT development? In fact, could any high-profile failures in this early adoption of agile in both the US and the UK and other countries around the world, could any such failures stall adoption of this interesting new approach to project management? And can the US and the UK and other countries learn from each other? So what we're going to do today is quickly have a look and see what the UK government strategy is on becoming more agile and delivering digital to the citizen, and then have a look across the Atlantic and see what happened at a case study from the United States, which exemplifies some of the problems of using traditional project management on on innovative IT development projects, and see how agile project management came to the rescue in a very large-scale project. First, the UK. Are we going to be going digital fast enough? The Cabinet Office recently announced a new digital strategy. And what they're saying is they're going to choose some Pathfinder projects, selecting major transactions such as student loans, universal credit and such like. And between now and 2017, about 1 in 4 government transactions will become digital. Then there's an inflection point. The pace of rollout will increase. Up to this point, the Government Digital Service, which is part of the Cabinet Office, will be helping various government departments understand how to implement digital and how to use this idea of agile project management, which we'll go on to talk about a little bit later. After this inflection point, we have rollout. By 2020, about 3/4 of major UK government transactions will be paperless. At least, that's the forecast and that's the intent. So the question that we're going to address together here today really is, what is agile, and what evidence is there that agile is suitable for large-scale projects? We need to talk to industry leaders about project management in terms that they understand, in business terms. There are 2 alternative approaches to project management. This is my thesis today, one of which is traditional, monolithic, big design up front projects, massive all-or-nothing IT projects. For example, the Smart Meter project, which we heard about last week, is now being delayed by 15 months. The National Health Service National Programme for IT, which was cancelled. And now we hear this morning about the High Speed 2 project, another big bang project, high technology project, not really IT based. That will cost £33 billion before there's any return. So is there any difficulty for the average person in the street, the business person or the general project manager to understand what is special or not about IT and technology projects? Let's look at this from a leadership viewpoint. And let's look at this. First of all, we'll have a look at the problems of big design up front. And we'll look at it from an everyday person's point of view. Homer Simpson. So you may recall this episode of The Simpsons where a car manufacturer wants to design a car which is going to be very popular, which will sell very, very well. They decide that the perfect person to design such a car is the average American. So they turn to Homer Simpson, and he writes down a big long list of all the things he would like to have on a car. A bubble dome, big long tail fins, a Rolls-Royce radiator, every feature he could ever want. Of course, when they try and build the car and try and market it, the car turns out to be totally unusable, far too expensive to produce. So this is an everyday example from a popular TV program, and we can use this to explain to anyone the frequent output from a big design upfront project. So when we communicate these ideas, there's another concept which Agile people often talk about, which is the tendency towards waterfall projects. What is a waterfall project? Here's an example. So we're doing a project here to develop a computer program or some IT, and we're going to take all of our requirements first. We're going to analyze and design the system, then we're going to program it and test it. And this is called a waterfall approach because when you've committed to swimming downstream, as it were, and you've got through to coding the system and you discover there are any problems, it's very difficult to return to a previous stage in the life cycle without a lot of rework and also a lot of argument and discussion. As difficult as trying to swim up a waterfall. And there we see the Change Control Committee trying to stop any changes because changes are expensive and they endanger the end date, even though those changes may be necessary. So we need to convince business leaders that there are fundamental problems with this waterfall life cycle on innovative IT projects. And when we're looking at IT projects, we often see waterfall and big design up front going together, like a horse and carriage. Things that are over-designed, too many features, they go together, waterfall and big design up front. And as we've seen in many collapsed IT projects, in government and large organizations, the results can be catastrophic. So let's turn to the question about what is Agile. I'm acutely aware of the fact that there may be people who are on this webinar who have heard about this term Agile, but are not sure what it means. And this is where we're going to have a quick poll. Great, so we've got 21% of people who are not really sure what Agile means, so we'll tackle that one in a minute. 31% of people, about a third, think that Agile project management can work in government. About another third say, well, maybe. 12% are sceptical and 4% don't think it will work. So we've got a hardcore there of about 1 in 6 people who think that Agile project management can't work in government. And of course we have about 1 in 5 who are not really quite sure what Agile means. Although now of course we've defined waterfall and big design up front, which is almost the antithesis of Agile. What we need is some proof that these new ideas of trying to get away from big requirements documents and the waterfall project management approach can really work in government projects. So let's turn to our case study. Let's look at this from a practical point of view. I'm not going to preach to you about Agile project management methods and step you through a plain vanilla case study. Let's have a look at a big, hairy problem. The FBI. So in 2001, the FBI had some real problems with its computer systems and its business processes. One of their agents, Robert Hansen, had been arrested. He'd been apprehended dropping off these secret documents and computer diskettes underneath this bridge, and he was about to leave to another point where he was going to pick up this $50,000 which had been dropped off by Russian secret agents. He'd been collecting money and diamonds totaling $1.4 million up to this point to shower gifts and cash upon a young lady he'd met in this club. In fact, behind this picture is a bit of a story. I found out the name of this lady that Robert Hansen was having a relationship with, and I found out she'd been interviewed on David Letterman's show. I found a transcript of that show. I found out she'd been working in the 1819 Club, somewhere near his offices in New Virginia. And a little bit of Googling, I found its address, found Google Maps, went into Street View, had a little pan around, and this is actually the 1819 Club. Recently, obviously it's closed down. Interesting what you can do on the internet, isn't it? So on 20 separate occasions he'd been leaving packages for Russians. So how did a single agent get access to so much diverse information and manage to sell it to Russian spies? And how could it be stopped from happening again? It's not an isolated problem. In effect, we're looking here at the business case for why they needed new computer processes, new business processes. Let's have a look at another one of their problems, the Oklahoma City bomber. Just as he was about to be executed, the week before he was about to be executed, it was revealed that 700 documents that the FBI had not been disclosed to the defense. His execution was delayed. It turned out the FBI had actually lost evidence and failed to disclose evidence. How could this have happened? How had they managed to lose all this information? They carried out an investigation. They found that they had an old, rudimentary mainframe computer system and terrible, outdated manual processes. It wasn't just computers, although that was part of what the problem was. It was the business processes that they were carrying out that were to blame. So they needed a much more secure and reliable set of systems and processes. And so what they did was they created a grand design for a huge, monolithic, virtual case file system. The project for a virtual case file. And they knew this was going to be a tough nut to crack. They planned out how long it would take to produce and how much it would cost, and they came up with the figure of $400 million. Of course, they decided this would be done in a very logical way. They would gather all the requirements together, they would build the system, they'd test it, and they'd put it live in a waterfall fashion. So they went about finding the requirements. 600 pages of requirements were listed. They started building the system. 200 people were working on this project at its peak. After the 9/11 attacks, $78 million extra was added to their budget if they could produce the system faster, because things were getting urgent on Homeland Security. So of course, being good project planners, they reduced the elapsed time on the overall project plan by squeezing all of the activities in, and they took the $78 million into their overall budget. But within a year, the classic systems of waterfall project failure had started to reveal themselves. Despite the $78 million of extra funding after the 9/11 attacks, it just became obvious that the project would not deliver on time. 600 pages of requirements were now the subject of over 400 documented change requests. 750,000 lines of code had been written and then worked and reworked again and again. You see, the system had been based on new web technology back in the early 2000s, but the testing that could have revealed the flaws in their designs came much later after the designs had been made, if you remember the waterfall model. So the testing that could have revealed these flaws came too late to change their direction. The deadlines were delayed again and again. Every year, the implementation date was put back by another 12 months. A classic sign of waterfall project failure is when every 12 months you put back the deadlines by a year. Major audits were being carried out. The Government Accountability Office, GAO in America, which is the counterpart of the British NAO, noted these slippage problems, but they took a very traditional view about what was needed. If only the waterfall process could be more perfect, if only the big design up front had been more carefully thought through and more detailed, these problems wouldn't occur. So after years of going round and round in circles, the project was restarted with even more controls and oversight, and another CIO, Zalmay Azmi. You'll notice he's the 5th CIO in 5 years, but he brought in fantastic leadership ability. He's an ex-Marine. He worked his way up from being a programmer to a project manager. He studied nights, and he carried out a lot of very hands-on leadership operations. After 9/11, as the dust was settling in the World Trade Center, the very next day he went in with a small force wearing gas masks to go into the US Attorney's office to secure the computers there and get them running again. He'd been out in Afghanistan crawling through the mountains looking for Osama bin Laden. If anyone could get the VCF project back on track, this would be the man. So 4 years into the project, he got them to integrate together the software that they built. He got them to test it. But hundreds of modules were failing the acceptance tests. And as the software was being fixed, they found further problems. So scores of basic functions had yet to be integrated. He talked to his boss, the FBI director, and the $170 million they'd spent up to that particular point in time could all be thrown away. They looked at the system, they tried to work out what the problems were, and they decided it was impossible to complete. And the FBI director cancelled the project. So this was the first attempt by the FBI to try and solve their problems of their insecure computer systems with a more modern workflow-based idea, the VCF project. This was a big design up front, a monolithic design with all of the modules being built at the same time and then integrated at the end. One of the post-mortem reports concluded that it was all the contractors' fault because they had, quote, badly bungled the project. The project should be abandoned. The software is incomplete, inadequate, and incompetently designed, essentially unusable under real-world conditions. So it's easy, perhaps, to blame the contractors when projects go wrong. And in this case, both the FBI and the GAO really failed to grasp that the project failure was due to the use of a waterfall approach, not because the design work had been inadequately thought through, but because the whole idea of writing a design before you start building and testing something is problematical. However, the GAO, the independent body, still concurred with the idea of a waterfall approach. Randolph Height from the GAO said, when you do a program like this, you really need to apply a level of rigor and discipline that's very high. But really they were missing the point. Even more top-down control wouldn't fix this broken approach. So in 2005, the VCF project had been cancelled, but the need for a new system remained, and Azmi was still the CIO. He'd been burnt by this particular experience, but he needed to deliver something new. In 2005, Leandro Aragoncillo was fishing for secrets in FBI computers. He was arrested. He'd been passing damaging dossiers about the President of the Philippines onto opposition members who were planning a coup. The ancient FBI systems that they still had to rely upon had failed to spot his suspicious behavior. Once you get up to a certain classification level on security with these old systems, you could really get into any file you wanted to. And Aragoncillo had been fishing through existing case management systems for over 9 months to get the information that he wanted to carry out his particular plan. So the need for a new system was still paramount. This is the business case that we have for this very expensive new system. So Azmi kicked off a new second attempt to modernize the FBI, and he kicked off the Sentinel project. So this Sentinel project starts off with a waterfall approach. Azmi still believed in the idea of this big design up front. At the time, a journalist interviewed him and noted that the roadmap for the project was housed in a 2-inch thick binder that Mr. Azmi frequently pats. Azmi had detailed plans which appeared to forecast that it could be done. The problems of the VCF project, the previous project, would be avoided this time. Stakeholders were told it would take about 4 years to implement, as long as they be patient. He spent a great deal of effort carrying out a beauty parade of contractors, carried out a big desk-based exercise scoring suppliers' proposals against comprehensive but theoretical statements of work. But eventually Lockheed Martin were awarded the contract, and they were given $305 million to develop the system. And to make sure that they had the right degree of scrutiny and detail and planning and rigor that everyone said that was needed with a project like this, $120 million were allocated for 100 FBI people to plan and check what Lockheed Martin were doing. Lockheed Martin themselves were carrying out planning and scheduling work. So in effect, a quarter of the dollars were being spent on one group of people at the FBI to watch what the other group of people at Lockheed Martin were going to do in terms of executing the contract. However, waiting 4 years for something is a lot to ask. So, to try and make things easier for the users in the meantime, they did what often happens on a waterfall project. They produced a temporary fix of screen scraping using a web browser. That means that the users would be able to log into the old mainframe computers using a web interface. However, what was really happening here was that these new screens may look pretty, very cosmetic, but they really weren't providing any new functions to the agents. One wag called it lipstick on a pig. The web browser did give access to the old system, but there were no new features, and in fact many critical functions were missing. People would have to log in to create a case using the web browser, but then update the case using the clunky old mainframe screens. And at $60 million, this was expensive lipstick. And soon people stopped using the system, because although they were pretty looking, the screens were incomplete, and often they had to go back to the old mainframe system to complete their work. In 2008, the 6th CIO arrives, Chad Fulgham. He came in from Wall Street, but he brought a business mentality with him that really said, show me. He wanted to see things working rather than look at paper plans. He favored quick results rather than the over-planning that was going on. All the status reports that his large project management office were giving him were very optimistic. There was this apparent comprehensiveness of project controls, very detailed earned value reports were being produced. But essentially, there was a lot of groupthink going on. History was repeating itself. The previous VCF project had failed, and now it looked as though Sentinel project would fail as well. So, Fulgham told Lockheed Martin they had to deliver outputs every 3 months, or else. The project, though, still remained very bound to detailed specifications and inflexible plans, and as functions were being delivered to the users, they found they didn't meet their real-world requirements, even though they met this big design up-front specification. So the technical approach needed to be reworked again and again. They had to keep swimming back up that waterfall, up to the design, change the design, recode, and test again. So, did this additional $120 million that was spent on duplicating and checking the detailed project plans really help? No. The project structure was large, unwieldy, and it exhibited a huge optimism bias. Status reports were full of facts and statistics, but they never reported even one part of the project as being in trouble. The status reports were never worse than amber green. Most of them were green all the time. Nobody had the guts to actually say the emperor had no clothes and actually the project was in trouble. So in 2010, we're almost a decade on from when we started this story, the stakeholders finally rejected the system. Even though it was theoretically compliant with the specifications that had been written down, it was essentially unusable, just like the VCF system had been beforehand. So this dream of implementing electronic information sharing at the FBI had been shattered, at least until Chad had a new idea. So let's have a look at attempt 2. This is the initiation of the Sentinel project with even more big design up front. A waterfall approach, of course, but a groupthink from the people who are looking at status reporting and forecasting and planning. Even though a quarter of the budget was being spent on planning and checking, forecasting and reporting in detail, it didn't stop a disaster from happening. So in 2006, 7, 8, we have this classic pattern of every year the project being delayed for another 12 months. In 2009, Fulgham pins down the milestones, and in 2010, after $405 million has been spent, that's on top of $200 million that's already been spent on the VCF project, Lockheed Martin were chucked out. One of the reports said that it would cost $351 million, that should be, not pounds, to complete the project. They were only halfway through, and they'd spent 5 years on the project. Fulgham decided to use a new approach, something that he'd seen working well in Wall Street, the Agile approach. He was going to take direct control of the project. So, he changed the team structure, prioritized the existing requirements to focus on the most valuable, rather than trying to build the whole system all at once. He reduced the project from over 300 people to just 45. And most significantly, he adopted an Agile approach. So you can see from the structure here, instead of project development teams, we have what are called scrums. Several scrums at the bottom level, and then a scrum master coordinating their effort. Each scrum working in short spurts of work to put things together and then integrate and test them before going on and making more detailed functions. A product owner, in effect, Jeff Johnson, the CTO, Chief Technology Officer, made decisions immediately at the end of each 2-week sprint, as they're called, of work, each iteration of work, as to what functions were the most important, what they should concentrate on, what they should be testing. And Chad was very involved with what was going on as well. So he ensured that the original monolithic requirements document was modularized into 670 separate user stories, each user story looking at one end-to-end process that could be built and integrated and checked, rather than building each part of the process separately as part of a big design up front. Jeff Johnson was responsible for regular negotiations with stakeholders to reconcile priorities and conflicts. But the key lesson they learned here was that there was the need for very short feedback loops, rather than waiting 4 years to develop and get user acceptance of the system. There were very, very fast development cycles, with automated building of the software and testing being carried out at the end of every very short iteration. So each iteration of work was a sprint of just 2 weeks. At the end of every 2 weeks, each scrum had to show that they built software, integrated it, and that it had passed its tests. So as a few sprints were carried out, it became possible to forecast the rough timescales and start to plan the dates for incremental business change. So rather than having a very detailed plan up front based on theoretical estimates, what they did was they measured what's called the velocity of the teams. Let's see how fast they're producing these 670 user stories. At the end of each iteration, you could work out what the velocity of the project is, and then dividing the number of user stories that have been produced up to that point in time, you can work out when the project is going to finish. More importantly, you don't wait until the end of the project to finish to deliver to the users. You plan drops of the software into the user community so they can start using it every 6 months. By June of last year, the system had been delivered using only half the budget that Chad had originally thought it would take. Agents are now using the system on real cases. And in the first quarter of its use, over 13,000 FBI agents had progressed over 600 cases, and the system has been meeting and exceeding all of its expected targets. And now, a few months ago, the old mainframe system has been turned off. So this is the third attempt at the FBI. They've gone agile, broken up the design rather than having a big design up front. They've iterated the development work and tested it regularly and shown it to the users to get real-world feedback as they've gone along. Each scrum or team of developers has been self-organizing, kept the number of staff down to a human level, that is 7 times 7 or thereabouts, 45 staff, not 300 staff. They've actually spent only $99 million. So what lessons are to be learned from this? This is almost like a scientific experiment. You've had 3 attempts within the same organization to implement a new computer system and new business processes alongside. The first 2 attempts have failed with a loss of $680 million. The third attempt, for only $99 million, has delivered in 2 years what the other 2 previous attempts had taken 10 years to fail to deliver. The research that I've carried out the last couple of years that's gone into my book identifies 9 leadership behaviors, agile leadership behaviors. If you talk to agile project developers, they often talk about how the programming is carried out. Pair programming, test-driven development, refactoring of code. Doesn't make much sense to a lot of business people. But these leadership behaviors are business behaviors. And these 9 behaviors are the ones that allow a project to become agile. And this would be my definition of what an agile project is, as opposed to just agile programming. Let's just focus on a couple of these and look back at our case study at the FBI to see what they mean. Being very incremental. Both Fulgham and his predecessor, Asmai, had to deal with non-performing big design upfront contracts. When they arrived in post, both of them broke the work into shorter phases, each 3 months long. So they required their contractors to start delivering faster. They did this so as to place what I would call a forensic spotlight on the failure to deliver, really, so that they could either get the contract to deliver or chuck them out. Unfortunately, in both cases, it was the latter option that they had to take. So in each one of these first 2 attempts at the FBI, this idea of having phased implementation merely flushed out the symptoms of this big design up front. It didn't solve the problem. What Fulgham did when he went over to Agile project management was that he managed to recover the Sentinel project by taking direct control of it. He thinned out the team and he focused on very short increments, not phases of work, but sprints of work that were just 2 weeks long. And at the end of every 2 weeks, the software had to be fully integrated, rigorously tested, and approved by stakeholders. He got real-world feedback from what the software was actually doing and how it was really performing as the team were developing, rather than waiting to the end of a 4-year project to find out whether the software and technology would work and would integrate into the business processes. So Fulgham helped his team to claw its way back to success 2 weeks at a time. The lesson here is that management became involved empirically. They got real-world feedback. They saw the proof of the pudding with their own eyes every few weeks, rather than waiting for status assessments by proxy through paper reports, committees, earned value reports, and so forth. So look at this second highlighted agile leadership behavior, light, tight leadership. This is what Fulgham brought in. Light management and light governance at the team level. The teams were self-organizing. They could work out which functions they needed to work on in each 2-week sprint because they knew what functions needed to be checked first. They knew where they had to investigate problems with security, performance. They knew which functions had to be built before other functions would start to work. The tight leadership and the tight governance came at the higher level. So the senior management were following very tight disciplines. They were deciding which of these user stories were most important for each 6-monthly implementation into the users. They were following what was going on at a very practical level, turning up for the tests, talking to the users and getting real-world feedback. That requires a lot of discipline. So in effect, they were doing a bit more than just delegating decisions to the teams, the scrums that were working for them. They were really making sure that the experts at the coalface were the ones that were making decisions at the detail. And the top management were making sure that they were enabling them and providing a governance framework which would protect the teams from shilly-shallying and poor decision-making. So Fulgham got hold of the risk and managed it directly. He didn't accept that Lockheed Martin were going to take all of the risk for failure. Sure, there may have been some sort of contract penalties for their failure to deliver, but in effect, the government, or in fact any large organisation, can't transfer all of its risks completely to its prime supplier. Risk always remains with the government, because no supplier can really bear the costs, the real costs of failure of government to deliver. We saw this during the Olympics when G4S failed to recruit the right number of security guards and get them ready for the Olympics. The fact that there were penalties and the fact that they are going to have to pay back whatever £1 million it is to the government is cold comfort to the Prime Minister, who had some international embarrassment in having to deploy the army to carry out security checks. So when we make the case for Agile to deliver to senior leaders, I wouldn't like to overstate the case. This waterfall approach can be unavoidable if, for example, you're making changes to mainframe systems. Waterfall can produce good outputs if requirements are stable, if there's a long-standing change team in place, and if the technology is well understood. But, and it's a big but, that's a lot of ifs. To wrap up, there's now an extensive literature available on Agile methods and best practice. At least 100 books on the subject on Amazon, but very few of them are giving you evidence and real-world case studies. Most of these books about Agile project management and Agile development are based on a leap of faith. What I'm interested in is an evidence-based approach. Stories like this FBI story that can convince business people to try this new approach. And what many CIOs have told me is that they need this credible evidence-based argument that puts the business case for Agile project management to top leadership levels. And I've been looking around the world to find these Agile success stories. What I'd like to do now is just go over to poll number 2. So we asked you a little bit earlier on, did you understand about Agile? Did you think it could be used in government? What I'd like to do now is rerun the same questions and see whether the percentages have changed. Well, that's fantastic. Only 2% of people are not sure now what Agile means. And in fact, for those 2% of people, which would be something like 10 or so people, I guess, I'd be very interested to have some questions from you as to why you're not sure about what Agile means. Maybe you need some more detail. Of course, in a very short webinar like this, there's only so much that I can say. There's a lot on the web, of course, but now we've got a good, I think, a good primer in the ideas of Agile from a project management point of view. 56% of people, so now the majority of people, believe that Agile project management can work in government. 1/3 of people say maybe, and we've still got 9% who are either very skeptical or don't think that it will work. And again, I'm very interested from that 1%, those 5 odd people who are still not convinced about Agile working in government. I'd like to find out why you think Agile wouldn't work in government. Very interesting poll there. What I've tried to do here is show you that Agile can work on large-scale developments, maybe not just in government, but also other large organizations, and give you a story here that you can use for your CIO, your senior management, the people working around you, so that you could reassess the next time you're thinking, your people are thinking of doing a large technology development based on a paper specification. So thank you very much. I'll just hand over to Anna Grabham and we'll take some Q&A.
Thank you very much, Brian. We do have a few questions for you. The first one is from Merv Wyeth, who's the chair of the Programme Management SIG, and he asks, is there an update on the UK government digital procurement framework and the creation of a neutral vendor with a budget of £100 million mentioned in your BCS presentation?
Yeah, since December, things have been moving very, very quickly with Cabinet Office. The idea they had around that time was that there would be an independent, neutral vendor who would put government departments in touch with expert developers so that they'd be able to create these digital solutions. You remember the graph at the beginning of my presentation was talking about 100% of large-scale digital transactions being paperless by 2020, but 3/4 of them by 2017. Now what's happened in the meantime is actually that they've changed their mind. They've decided that they're not going to let this out to a neutral vendor. They're going to manage this internally, and the government digital service, which sits within the Cabinet Office, will be managing the development and helping people in the different departments of government with these Pathfinder exemplar projects. That's the positive spin on it. one point of scepticism I would throw in here is the fact that the government's ICT strategy, which was announced nearly 3 years ago now, said that by April 2013, half of all large-scale government IT projects in Britain would be using Agile project management. As far as I know, that was last month, and half of IT projects in this country haven't adopted Agile project management. I'd imagine it would only be a dozen or so projects that are past the way through. So I think there is a disconnect there between the stated strategy and the targets the government set themselves 2 years ago and where they are at the moment. Next question, Anna.
And the next question is from Nick Wensley, who's co-chair of the Benefits Management SIG. Agile is not just for technology projects. It is almost universally applicable, is it not?
Oh, I don't know if that's a leading question or not. Out of interest, I took the APMG Agile Project Management examination last year just to see what sort of case study they would use. And the case study they used was actually one of refurbishing a hotel. And the idea was you could either refurbish the hotel by having this big design up front, a grand scheme for what you were going to do, and then spend 6 months. You'd close down the hotel, you'd refurbish and have a grand reopening, not knowing actually if that's what the public really wanted. And the case study was that the management decided to refurbish the hotel using Agile project management. So they were getting the electricians and they were getting people to carry out work on certain buildings in increments. And you put the new facilities into operation depending on what customers wanted. For example, the conference hall and banqueting suites for weddings in the spring, outdoor activities for the summer, and so on. And they divided things up into these various different leaps of work or releases for use. And inside, during the refurbishment work, you'd have technical work going on, but not computer work. It would be plumbing and electrical work and so forth. And the questions in the examination were based upon applying Agile project management in a non-computing environment. I thought that was very, very interesting and quite credible, I think.
The next question is from Chris Moore, and Chris asks, surely the success of Agile adoption not only relies on evidence of where it's been adopted elsewhere, but an understanding of how the culture had to change to adopt it.
Yeah, culture change is one of the most important things that happens with Agile project management. I suppose what I've shown here is the idea of taking a problem project and sorting it out using Agile. The most popular way of adopting Agile is not in a crisis, but planning its rollout and starting it off with exemplar projects, as GDS are going to do in the government departments. And then you're looking at sort of hearts and minds efforts of culture change, provision of tools and technology, training, and so forth. And the biggest difference between myself and some Agile practitioners on this is that I think Agile should be implemented in an Agile fashion. In other words, in increments, a bit at a time, rolling out in a gradual way, rather than a total culture change all at the same time. I think some people who are pushing for Agile project management are saying that you should have to change everything at once, throw out the baby with the bathwater, start from year zero. I wouldn't agree with that at all. There's a lot of value in a lot of the ideas in planning and tracking and even earned value management, which I've mentioned a few times and I might have sounded very skeptical about. I think these approaches do have a lot of value in measuring velocity. It's just that Agile turns these concepts on their head. So you're measuring velocity rather than trying to measure how good people were estimating on a theoretical plan in the first place.
Neem Shannon asks you, please can you describe the role of Scrum Master, and are there typical ways for Scrums to self-manage, or are they so small and fast that they don't need more formal methods?
Sure. The Scrum Master is more like a person who's herding cats, I guess. One of the chief tools that a Scrum Master has is talking to people. So one of the chief things that happens within each sprint, which lasts, say, 1-2 weeks, or in an XP case, I guess it could be a day, the Scrum Master gets people together at the beginning of every day. You have a stand-up meeting. So not a meeting where you're sitting down eating croissants and talking about theory for 2 or 3 hours, but just a meeting where people bring all of their problems. All the problems their teams have encountered the previous day, and what needs to be fixed right now. So the Scrum Master gets those people together and works as an issue manager, if you like. Now, Scrum imagines really that most of those issues are going to be sorted out by the team itself, and that maybe a product owner may be involved at some point. I think when we're talking about agile project management, especially in larger projects, we're talking about that team of people, that Scrum Master then going up and working in a scrum of scrums. So he then goes on from that meeting and has a meeting with other Scrum Masters, up to maybe 6 other Scrum Masters, and they chew the cud and they talk about the problems that they're seeing across the piece, across the user stories that have to run from end to end. Above that, I think you're still into issue and risk management, and I think this is where traditional project management has a lot to add in terms of actually tracking stuff up to the product owner. You see, the Scrum Master is meant to be looking after this thing called the product backlog, and that's a list of all the features that have to be in the system to provide the facilities so that you can carry out the user stories, these business processes from end to end. Now, obviously, you can't just handle the issues that are coming up through the team. You have to think about external issues as well. I touched upon the importance of data conversion, interfaces, and so forth. You have to then roll in risk management. Can you have proactive risk management worked into this as well? So in terms of self-organizing, the other question, Neve, was about self-organizing teams. This really is about which people need to work together. So if Fred and Joe need to work together one day and then Mary has to work with Joe the next day, they decide to do some testing at lunchtime, let them get on with it. It doesn't have to be on a detailed team plan. Everything that happens within that, say, 2-week sprint is something the team works out for itself. It's just the overall structure of having the daily stand-up, maintaining the product backlog of all the work that they've got in their queue of work to do, and always delivering at the end of that sprint. So if you can't do all of the things you were planning to in your sprint backlog, you chuck out the things which are optional, you stick to the things which are really important, because you know on that last Friday you have to give a presentation to the directors and user stakeholders, because they're going to be coming on with some of the real live software working. You can't delay that meeting, so you chop out optional functionality and you deliver, you chop back the scope to meet the timescales. That's why Scrum's Agile looks at things from a different perspective, from the usual perspective of delaying a project to deliver all the functions. No, cut the functions, deliver on time.
Thank you, Brian. Peter Parks says, great story. And can you tell us more about the use of user stories versus requirements in Agile?
Different people have different ways of providing user stories. The important thing here, I think, is to not do too much in terms of theoretical documentation. The important thing is to outline what a user transaction looks like, or even a long user transaction. So in the case of the FBI, you might have a case comes up with somebody who's a suspect, then they're tracked, evidence is put together, and then it goes to court, and the information has to be disclosed to the prosecutor and the defending counsels, for example. That's a sort of what they call an epic. That is where you have several user stories, the creation of a case, the tracking of a case, the closing down of a case, into an overall story that spans a period of months, maybe, or years. So different methods. We talked about XP, we talked about Scrum, DSTM. There are things called use cases, which is a Scandinavian bad translation of English really, but that's where you have a particular case and you're actually tracking its use all the way through the system. And there are diagrammatic methods that you can use to put these forward as theoretical concepts. But the important thing is to get the technologists building the technology and the users thinking about their business processes so the two can work together and you can test those at the end of every sprint. Getting to too much diagramming and theoretical abstract modeling can be a real problem, and Agile people try to avoid that.